Wow. So who here has used a ZK Snark before? Amazing. Who here has written a ZK Snark circuit before? Okay. Who here has verified a ZK Snark before? If you've ever run an Ethereum node, you've verified a ZK Snark. Who here has verified a ZK Snark with their own bare hands? No, just kidding. I haven't done that either. Okay, well, great. So welcome, guys, to the privacy panel. I talked about privacy a lot in my presentation, and Tony talked about stealth addresses, and we're going to keep talking about privacy over the next 3 days because privacy is a super important topic, both because privacy is a human right and an incredibly important thing broadly, and also because of how it's like uniquely important in the given how blockchains as a technology kind of start with zero of it, but at the same time there's all of these technologies that can give us much more privacy back. And so what I wanted to talk about is both the state of privacy today and what we're doing to try to do more, what can we do more, and what the future of improving people's privacy in our lovely Ethereum ecosystem looks like. So maybe, Barry, to start off, one of probably the biggest technology that people are using right now for improving privacy is ZK Snarks. So could you maybe just introduce what ZK Snarks are and what kinds of things people have been using them for?
Sure. So one way to think about this is that like ZK Snarks are like the language of truth, that you can create this system where you're only able to say true things. And like ZK Snarks are a tool to do that. So you're able to make this kind of like specialized circuit that you can only make you can only prove that it's true. Like you can only prove that like inputs like, okay, let me try and say this another way. So maybe it's good to give a motivating example here. And one example of an application that we often want to do is to make a proof that you're a member of a group without revealing like which member you are. And zero knowledge proofs let us do this. They allow us to make these proofs by using some kind of clever mathematical tricks. So we can use it for like that simple use case where we're using the benefits of ZK Snarks for privacy, but we can also use the benefits of ZK Snarks for scalability. Because it turns out when you have this technology that can compress the verification of a program, you can compress it. You can use that for scaling purposes too. So another example is like ZK EVMs. So some people are using ZK Snarks to make proofs of like the Ethereum virtual machine has been computed correctly. And like I kind of think of like this as like the first step on a long journey. That like right now we're able to make a proof about a virtual machine that's the equivalent of what a mobile phone could do in like 1995. Like we still have a long way to go in like the set of things we're able to make proofs about. And my expectation is that we'll eventually start making proofs about like almost everything that we do.
Makes sense. Maybe also just introduce a bit about yourself and what you're up to in the Ethereum ecosystem. How you got in here, and what you and your privacy stuff is all about.
Okay. Hello. Yeah. Okay. So I've been in the Ethereum ecosystem for like 10 to 7 years. And I've been, like, I originally got involved because I really wanted to make things. The first thing I wanted to make was, like, I was really interested in, like, cooperative movements and how people could organize. And I wanted to make an application that would sort of prove this concept, so I decided to try and make a t-shirt purchasing cooperative. So basically people would pool their money and they would get, like, a bulk discount on purchasing t-shirts. This is where I started trying to, like, build sort of community projects. And since then, I've sort of branched out into doing a whole bunch of things in the kind of private realm. And I think that like when Ethereum forked to include like the BN254 opcodes, the things that makes ZK Snarks possible to verify on Ethereum, I got super excited because it was just this whole world of things that we were able to do. And so I started to make like some proof of concept applications and tried to start to explore. From there, there was so much to explore. It was a very exciting time, but it was also like, there was like limitations in what I could do by myself. So I started to like work with more people, some people in the Ethereum Foundation and some people outside. And together we've been like, as a community, we've been trying to push forward zero knowledge proofs to become like the technology that we really need. Because in today's world, it's very difficult for people to be able to have privacy in their lives.
Okay, and maybe Tony, just for people who weren't here an hour ago, kind of introduce yourself a bit and like how you got into the space and some of the stealth address stuff you've been doing.
Sure. Test. It works fine. Yeah, I'm Tony. I came into the privacy stuff through Bitcoin, so I started using or focusing more on privacy technologies back on Bitcoin, where the most promising or the most prominent privacy tools are CoinJoins, where you have these unspent transaction outputs and you just bundle them with a lot of other people that you don't know. You mix them together and then you create one transaction that spends to, again, to yourself. So it's kind of a mixing on Bitcoin. And it's quite old. So on Bitcoin, I think it's almost 10 years old by now. And yeah, that was kind of my first experience I had with privacy on public blockchains. I then got to Ethereum and found that Tornado Cash was a really cool application. Did more research into CK snarks. Wanted to know how Tornado Cash works. And finally, 2 steps back, stealth addresses, which are much simpler, much less complex than CK snarks, just using elliptic curve cryptography. And this was then the point where I thought, okay, this is really something that can be rolled out very quickly, that a lot of wallets can adopt, that can be standardized, very simple. And although it doesn't give you the same privacy like Tornado Cash or CoinJoins, because both of them, Tornado Cash and CoinJoins, they give you untraceability, which always requires some mixing to be involved. Stealth addresses can only give you unlinkability, which is for many, many applications already sufficient to be used.
So in terms of specifically privacy for coin transfers, right? Like there's over the last 10 years, it feels like there's been this kind of progression, right? Where we started from CoinJoin, and then we went to Monero, and then Monero started, supporting like more mix-ins, and then we started having Zcash and Tornado Cash. Could you maybe kind of go through this sort of sequence of technologies and like what is the thing that we've been gaining and we've been getting better at as we've moved further and further toward the more powerful cryptography?
Yeah, sure. So stealth addresses so the first privacy we had on public blockchain was essentially Satoshi proposing pseudonymous accounts that are just accounts that you cannot link to a real world entity. So everyone can create a new account, which is already a lot of privacy that we get. Then a few years later, already in 2011, the first stealth address proposal was proposed, which required the sender and the recipient to generate a shared secret, so a Diffie-Hellman secret. And if you hash the result of the Diffie-Hellman secret, you can use that as a private key that can be used between 2 entities, more or less. Then stealth addresses were continuously improved, and very interesting story, in 2013, there was this pseudonymous entity, Nicolas van Saberhagen, who is still pseudonymous. He proposed a CryptoNode white paper, which then laid down the foundation for protocols like Monero, Zcash, and so on. And the CryptoNode white paper already included stealth addresses, it included ring signatures, and it also included the first snarks that have then been adopted and slightly used differently, but came into the Zcash protocol. And yeah, then more or less Tornado Cash was then the first application. I think it was the first application that then built these Merkle trees where you can then prove to be part of a group without revealing which exact entity in this group you are. And this then allowed users to deposit funds, prove that they have deposited some funds and then move the funds out of the contract again without revealing which exact address they used to deposit.
Great. So that gets us into financial privacy a bit, right? Maybe, Barry, could we talk about some of the non-financial use cases and like some of the specific ideas that either PSE or some of the other groups that we've been working with have been trying to do, and how some of the ZK Starks help provide privacy there.
Sure. So one thing that's like financial privacy is exciting and it's interesting and it's useful, but there's a whole bunch of other like interactions in our world that are not like financially based. Like one example of that is like reputation. Right? That this seems like this a very powerful primitive that like you use much more often than money. And like being able to have privacy for reputation is also like at least as interesting as having financial privacy. So one example of this, one example use case of this is that like at Zuzulu, the 0x Park community members made this ZK passport. And basically it's like a proof of residency at Zuzulu. And basically, anytime you want to use this proof, you can provide the zero-knowledge proof to someone, and they can verify the proof. They become convinced that you are in fact a member of the group, but they don't know which member you are.
What are some of the applications that the ZooPass got used for?
Right. So ZooPass originally started as just like a ticketing thing. It was just like to enter into venues and stuff. But people have managed to build a whole bunch of interesting things on top. One example is something called ZooCast, which is like this kind of ZK Twitter, where you're able to post about being like a member of Zuzulu and like post whatever tweets you want. And there's like, I think it's the URL is zoocas.st, is ZooCast. And you can check there and you can see a bunch of the fun discourse that's been going on.
Great. Any other particular non-financial applications that come to mind? Either of you? What are your favorite non-financial applications that we could have much more privacy in?
Oh, so I really like the idea. There's this algorithm called eigentrust.
Right.
And basically the way that eigentrust works is that like you can, given like a graph of connections between people, you can calculate the like global trust score of everybody in that graph. And I think that this is really interesting because our world is very like humans are very network focused things. Like they understand networks a lot better. Like the concept of like a friend of a friend is a lot more natural and intuitive than like a lot of other concepts. So like making a ZKP for eigentrust would be really fun. So you can prove that you have a certain score without revealing like who you're connected to. So I think in general, like ZKPs about social graphs can be really interesting. There's another algorithm called Sybil rank, which might be fun to explore as well.
Yeah. One possible application that would, for example, in the last 2 years would have helped us a lot would be, assuming now we trust the government, right? So the government could just have put every vaccinated person also into a Merkle tree and allow people to prove against that Merkle tree, providing a zero-knowledge proof that they have been vaccinated. And this would then would have allowed people to not expose their identity anytime when they visit a restaurant and have to prove that they were vaccinated or something like that. So that would actually be not that complex because the government would just be this central entity having the power to update the Merkle tree, to add every person that has been vaccinated, for example, into that Merkle tree, and then people could submit zero-knowledge proofs to show that they have been, that they should be allowed to go into a restaurant, something like that. Yeah.
And that would be basically exactly the same technology as ZooPass, right?
Right. That would more or less be the same, and it's also actually the same like Tornado Cash. Only Tornado Cash works decentralized, so there's not one central entity that is allowed to add the leaves to the Merkle tree and nullify them.
Right.
But it would just be the government in this case that we trust anyway in this case.
That makes sense. What are some of the technical challenges that both of you see that we still need to solve before we can see much larger scale adoption of these kinds of technologies? Like how long before people in Montenegro are using, ZK payments and ZK voting and ZK reputation and all of these things?
So like normally the problem is approver time, especially on like low-powered devices. ZK snarks still require like a lot of work in order to be able to create the proof. And you can think of this as like it's work to create the proof so that the verifier has to do only a tiny amount of work. So for me, this is the biggest bottleneck. And let me, like, with Semaphore, the tool that's being used in ZooPass, where the prover time is not an issue anymore, it's very highly optimized in order to be able to work. You can make proofs on mobile in less than a second, and even with bigger groups, you can do this. But there's some other issues. For example, if you want to make a proof, you need to download a lot of data. You need to download that you're like a member of the tree, and you need to download a proof that you're a member of the tree. And to do this download, you actually need to download all of the data, because if you just download some of it, then the person who gave you the data will be able to tell who you are. That we might have to explore some things like private information retrieval and things like this in order to be able to like make really bigger groups. But I think, so let me slow down. I think that like, I feel very optimistic about like the example of people in Montenegro using ZooPass to prove that they have received a COVID vaccine, for example. I think that that's practical today. And I think if we want to do like more advanced things, we still need to like improve our prover infrastructure.
Okay. What do you think, Tim?
Yeah, I would definitely agree to that. And I think, so for all the people that have never used the ZooPass, this was really this very straightforward way to it felt like logging into something, but without revealing who you really are. You just revealed, I'm allowed to log in here, but I won't tell you who I am. And then after this layer of logging in, you could just participate in what was offered there. And for example, you could just truly anonymously vote for things or tell people how you feel and stuff, and without really revealing who you are. And I think when it comes to mainstream adoption, people always need something that they trust. And if we can prove that the technology behind it, so no one can build in a backdoor or something like that, then people might feel really comfortable using it. And yeah, that's essentially my point.
How worried are we about bugs in these systems, right? Because the more private the systems become, the more like bugs and abuse of bugs becomes just totally undetectable. So how do we mitigate this?
So this is something that worries me, especially because the systems that we're using are very new and very complicated. We've also built on top of primitives that are very experimental. For example, there's this saying in cryptography, don't roll your own crypto. But for ZKPs, we have a bunch of specialist crypto that we're using. For example, the hash function we're using is like a snark-friendly hash function. So this is a concern, but you see, what I see happening is for us to move away from like the reason we need to use snark-friendly hash functions is because the proof system is not very efficient. And I think with like a couple more generational improvements in zero-knowledge proof technology, we'll be able to replace the snark-friendly things with snark-unfriendly things and start using standard primitives.
That's interesting, because I would have, like, my guess would be that if one of these things gets broken, there's like a less than 5% chance it's the hash function that's the problem.
Really?
Yeah. Like just the complexity of these, 100,000 line circuit files in general.
Okay, right. On what timeline?
Next decade.
Okay. I suppose that like the way I reason about the circuits is that like it's okay. There's a lot of constraints in the circuit, but it's normally the same thing, right? It's a Merkle, like for Semaphore, for example, it's a Merkle proof.
Right.
Right. It's just hash, 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 hash.
Okay, I guess I have in mind like a ZK AVM.
Yeah, absolutely. That's another level.
Right. Okay. So it's interesting. There's like different use cases that have different threats around this. Okay. Maybe just it's like as far as use cases go, maybe talking about one more. So ZKML, there's been a lot of excitement about AI recently. Like how, I guess, excited are you about the possibility of using ZK to kind of improve the verifiability, privacy, trust properties of AI? Do you think this is a, do you think this is a good direction? Is this something that excites either of you personally?
Interesting. So, okay, so there is some nightmare scenarios here where there's like just an advanced AGI that's on-chain.
Right.
And it pays people to train it, improve it. And it pays people to like execute it and pay for it to think. And this is like 100% decentralized and there's no way to shut it down and there's financial rewards for everybody, for anybody who participates. So this is like one thing that could be very scary. But like the place I see ZKPs helping is more on like the proof of individuality level. That I like the way I think about it is that I see the development of AGI as being like another way of losing like authenticity. That like it started with the internet when you could make many symbols and it's just gone more and it's just become easier and easier and now you can impersonate a person writing a PhD thesis or whatever. Like you're able to like produce this incredible body of work and you can fool many, many people. So I think that that's going to become super important.
Okay.
Yeah, that's very interesting actually, yeah. I guess we are currently all experiencing that we are interacting with different models more and more. And I'm definitely not an expert on CK machine learning, but I think in the future we will need some proving which machine learning model we are actually interacting with right now. Probably what data it was trained on and all that stuff. Yeah, so just to know with what exact model we are actually interacting with, because it might be, we might have different models for different use cases, of course. Some are much more sensitive depending on the application. And at this point, I definitely think that some proving of which, so what the model exactly contains, what it was trained on, what's the properties of the model, and so on, is definitely something that is very required.
That's a good one. Okay, maybe last set of questions is, so people often argue, sometimes argue against privacy by basically saying that privacy gets abused by bad actors, basically, right? And people make this point in AI and for finance and for social media sometimes. So, are there ways that in which zero-knowledge proofs could be designed to still give people privacy, but at the same time kind of remove the risks of bad actors doing some of the worst things that they might otherwise be able to do?
Yeah, definitely. So I really like the quote you had on your talk about giving privacy to the weak and forcing transparency to the rich or to the powerful. So this is essentially, I would totally sign that. And I definitely think that when it comes to privacy, often the first world countries, we don't have issues with privacy. We can just interact with organizations, have standpoints that are against our political parties and so on without facing real issues. But especially thinking of developing countries, it's not that easy, and they should not be forgotten in this discussion in this case, because when we build privacy tools, yeah, there might be some people exploiting the privacy for selling stuff that should not be sold, but more or less privacy is very, very fundamental. And there's also this quote, I don't know it by heart, but without privacy we won't have freedom and stuff like that. So although privacy might be exploited by bad actors, it's still a very positive sum game for whole society. Yeah.
There's also a whole bunch of places where we really need privacy that can make our world much better, even for the people, even to help solve some of the problems that businesses face. For example, there's one project called Proof of Solvency, where an exchange or a company can prove that they have enough money to pay everybody who owes them money. And like this becomes like a really natural way to allow to have like the privacy that like a business needs in order to function, while also providing society with guarantees that like everyone is able to get their money out.
Okay, so very optimistic future for ZK Starks and privacy technology. Thank you, guys.
Thank you.